realistic futures of AI. What is AI research really aiming for in the near future? One of the things I'm really excited about with this keynote panel is I'm pretty sure none of these panelists have ever spoken together or interacted much before today, which is really exciting. So we have Kenric McDowell, who is the creator and founder of Artists and Machine Learning, Artists and Machine Intelligence at Google, a cultural arts and I guess technology initiative to sort of pair artists and research who are working in machine learning. We have Momennejad, who I'm a big fan of her work. She's doing a lot of neuroscience on machine learning and memory. And right now she is a postdoc at Princeton. And we have Madeleine Elish, who's with Data and Society, who one of my favorite pieces of work you've done is actually the AI pattern language library with Tim Huang. So I'm excited to kick off this panel.
Thanks, Caroline. And thank you, Tomiko and Caroline, for inviting me today and for putting this, bringing all these incredible people together. It's, I go to a lot of these things, and this is definitely a very cool moment that we're in together right now. So I'm going to give a little introduction to the program that I run, talk about a couple of the projects that we do, and sort of some of the main motivation for us. And in the process, I'm going to share a sort of finding, you might say, through this mode of research that we do, which is intuitive and creative and imaginative, but also about joining up with the technology production process and the computer science process of machine learning. So, as Caroline said, we're called Artists and Machine Intelligence. We've been around since the mid-2015. We officially launched in beginning of 2016. We are now we started in research, but now we're officially a collaboration between Google Arts and Culture and the research group at Google. We work mostly with research, but we also work with people all over Google. The beginning of all of this happened in the summer of 2015 when this image called Trippy Squirrel leaked onto the internet. This was part of something called Deep Dream, and I think that Trippy Squirrel is actually responsible for everything that we've done, in the fact that it escaped the confines of Google and made its way to Reddit, where it started a lot of buzz, which led to our first show at Gray Area in San Francisco, and this is one of the pieces from it. This is the kind of thing that you're probably used to seeing if you know anything about generative machine learning for artistic applications. It's dog slugs and weird critters like this. Google tried to kind of get out ahead of the narrative and say, hey, like, this is what's happening. We're looking inside of neural networks. But of course, people are really more interested in telling the stories that are exciting to them and that they know, like Google's Dream robot is running wild across the internet, or Google's artificial brain is pumping out trippy and pricey art. Now, none of these things are technically true at all. They're obviously like great clickbait. And you know, part of, I think, one of the things that we've seen as we do this project, collaborating with artists and machine learning researchers and computer scientists, is that what we need really is a better narrative about what's happening. And so that seems like a lot of the discussion today has been partly about that, and I really appreciate the concreteness of what's being offered in terms of policy, in terms of what things are. But my kind of job and my history as a design prototyper and someone who works in speculative design for AI is to sort of imagine things that haven't happened yet and to sort of take into account future possibilities that, you know, we may have more or less certainty about, and speculate on what we can do to enter the future in a way that makes sense. And so this next slide is kind of a formulation that I came up with from trying to communicate a lot of what we've done and to looking at sort of scientific research that came across my radar. And so there's been some heated discussion already, which I really appreciate, about the validity of, you know, authoritative speaking about science and insights and stuff like this. And so I'm just going to caveat this by saying, like, this is a story, okay? And the story is that new tools have a generative capacity that actually, they generate things within us. And so let's just take a moment and admire the beauty of this 300,000-year-old hand axe. This was made with a process of chipping stone, flaking stone to produce this tool. And Dietrich Stout at Emory University did some neuroimaging studies of people that were undergoing the process of learning how to make these stone tools. And the finding is that this process of creating these tools actually strengthened areas of the brain that are associated with gesture and implicitly with communication and possibly language. The point being that new tools produce new structures in ourselves that actually generate new things. And in this case, he's speculating that perhaps tool making preceded verbal and spoken language in the sense that we needed to develop pieces of our brain that had maybe the latent possibility of producing language. So what I'm saying here is that we're actually in the process of making new tools, changing ourselves and making new languages that we can use to understand the world and engage with it. So I'll take the example of photography, which is my kind of field of study. This is what I got my MFA in. And I think you can actually go all the way back to paintings like Hans Holbein the Younger's Ambassadors to see a photographic imperative in art making in the sense that there is a lens-based approach. This anamorphic skull looks like this in the image in the original painting, but it could only be, if this kind of deformed backwards, you realize it could only be produced with a lens. So we have a sort of model for photography that goes back quite far through daguerreotypes into color photography, conceptual photography, minimalist photography like Ronnie Horn's You Are the Weather, into something even newer with neural nets and generative image making with neural nets like this FaceNet hallucination by Mike Tyka, who's one of the engineers and artists that works on our program. FaceNet is a neural net trained on faces. If you use the same type of generative technique that you would with Deep Dream, you can produce faces of like theoretical humans that might not exist, and we call this a hallucination. So just to paint that picture a little bit, the hand affiliated with the lens eventually intersects, with film, with the CCD, with the big data archive, and now with neural nets into sort of create a type of photographic language that's evolving along with AI. So the question is really, what new language does AI art produce? And I felt that this was a necessary question to answer because of my own experiences of looking at it and working with it, and I'll show you a couple projects that we've done. But there's one aspect of it that I think is really relevant to our sort of understanding of the world, which is that there's a high degree of multidimensionality within the mathematics of an AI system. And so when we talk about dimensional translation with T-stochastic neighbor embedding to reduce a 500,000 dimensional neural net into a, okay, 5 minutes, sick. I'm gonna have to go really fast, sorry. We basically have a multidimensional paradigm that we need to use to think through problem spaces. And so there are certain new languages that are revealed in that process. So sometimes they're quite literal, and this is a project we did with Ross Goodwin called Word Car, where we drove from New York to New Orleans with a poetry generating AI attached to a car. These photographs are by my colleague Christiana Caro. It produced this kind of poetry and images, and the sort of apparatus of this machine was the infrastructure really of capitalism. So we have a surveillance camera mounted on a car, we have a neural net generated using tools that are used in corporations, and we have also we have a Cadillac driving down a freeway, and we have access to the Foursquare API, which produces, these are the decisions that Ross made about which elements to include in this assemblage. And the knowledge that this thing had of the world was largely knowledge of how to get fast food on the interstate. And so that really, that tied in. Obviously, this was a sort of literary project, and there were elements of the literary road trip as precedents, this very kind of American notion. But there were also aspects of food production and agriculture that got folded into it as a result of the choices that Ross made in producing this. There's a sort of relational quality that is inherent in these MI projects. So when I was saying, dimensionality reduction, there's this process called T-stochastic neighbor embedding that we used on a project with Rafiq Anadol. You can see some of his projection mapped art here at the LA Philharmonic. But the project we did was with the Salt Museum in Istanbul, and it was, to invoke Borges again, it was a model of their archive that became a sort of like endless library of generative imagery. So it was built into an architectural installation. It's called Archive Dreaming. There was this sort of reflective surface for the ceiling and the floor that produced this infinite tunnel, and then there was a browsable interface of images that were clustered using these machine learning techniques. So you can see the sort of totality of the archive here, represented by similarity of features using image recognition neural nets, and someone using it in a more kind of analytical mode. But there's also, well, this is also another sort of display of the connectivity between surfaces of images. And then there was a generative capacity, which I won't show you the video, but we hallucinated the neural net of the archive to produce hypothetical documents that might not have existed, or that could have existed but didn't historically. So a sort of hallucination or a generative archive. So I'm going to try and wrap up just by saying that a lot of what we've seen today, when we're talking about the influence that these new technologies have, it's not just kind of on this level of like linguistics, but actually, you know, real more pragmatically, when it comes to policy, it has a lot to do with the social contract. So whether we're talking about like predictive policing, specious notions that are phrenological about understanding somebody's interiority based on their epigenetic expression, tools for organizing society in this automated way, and ranking citizenship, similar to credit. These are all, you know, deformations of the social contract that we're not dealing with very well, right? We kind of snap to the narratives that we have. So just one suggestion would be this lecture that took place for like a deeper take on this at Google by Yuval Harari. And it's a little bit more of like a 200-year look at some of the influence that this might have on our sense of self in regards to society. I guess I'll kind of try to wrap up here. I have a whole bunch of references I'll just like blast through. But my kind of orientation to this is that actually in order to understand the social contract, I kind of omit this line in between contract and ontology, which is ideology. We need to actually understand what our ideology is. And we don't have like adapted ideologies to the new situation that we're living in. And in fact, if we go a little bit deeper than ideology, we discover that ontology is actually the issue. And my personal point of view is that we need an ontology that can include ourselves as members of a network, that can include the landscape, the city, the crew, the individual as aspects of one's being, where we are no longer sort of a single individual. And in the process of being part of that network, we might be able to model a type of AI that would bring into our area of concern animals, plants, you know, people that are not given the full status of personhood for whatever reason. And that ontology, I think, is actively being constructed. There are people that we've worked with, we've brought in philosophers, artists to work at Google and consult on our AI strategy as a part of this AMI program. So one of the really nice things that's fallen out of it is that actually we can just have a direct conversation with people that are experts in the field of ontology, which is, you know, the sort of definition of what being is, what it means to be, what the world is. And so I'm just going to blast through some of the like reading that I think has been really influential in this process of kind of constructing this pseudo stack of thinking. So, you know, getting to what is happening online with culture right now. This is a pretty great book. Some like big scale formulations of what technology is in terms of its relationship to national sovereignty and individual citizenship. What is actually happening politically with zoning and how what the political world really is. We are kind of like living in this like state of like anamnesis, and we need Gnostic revelation of the true political state of the earth. Deconstructing and hacking our notions of gender into a more complex multidimensional reality. Dealing with alienation in positive ways, hacking narrative of alienation, embracing it, possibly subverting it. Building political theories that take into account our solidarity with non-humans, and looking to the intersection of areas of culture that are completely outside of this bubble that we're kind of all in, right? How are we intersecting, how is this techno-capitalistic mode intersecting with areas of knowledge production that don't have the same underlying assumptions? You know, where is this happening? So, again, this is, you know, maybe there is an ontology where Trippy Squirrel has more existence, and maybe we need to acknowledge what that is. And I think, you know, for us, art is the most the freest and most imaginative way we can do it in dialogue with the people like yourselves here who are trying to bring it down to more tactical implementation. So with that, I will hand it off to Ida. No, we're going to keep it on this one. It's all on this one.
Hi, everyone. Thank you so much, Kenric, for this presentation. I found a lot of it really interesting. And this thing is loaded on this screen, so I guess I should take it to the other screen.
Oh, you might need to.
Yeah. Hello. Okay. So, I'm Ida. I'm a neuroscientist, a computational one. And what I do is I look at how, using machine learning, we can figure out how humans store things in memory and how they update those things that they have stored in memory and how they use it to plan the future, so inside human brains, and also how interactions between networks of people changes their memory and their agency. So I'm very interested in what does it mean, what is it to have human-like memory and agency, and in fact I'm using machine learning to get at that, so using computational models to figure out what human memory is like. So it's a little bit different from the perspective of looking at AI as this sort of a Terminator scary thing. One thing that I was crazy about is I grew up in a war in Tehran, and I used to go with my dad flying kites, and I could hold something here, and something very far away from me was controlled in spite of the uncertainty of the wind. That's what I'd like to describe as distal agency, a situation where there's a lot of uncertainty involved, but you can control something in spite of the fact that it's further from you, it's not immediately next to you. I think that likewise, we have proximal agency, which is things that are in the sort of the reach, and then distal agency could be enhanced by institutions, by tools, by algorithms, by other means. And we could sort of enhance with institutions and with people that might be on the way our agency. For instance, I could ask Caroline to bring me a glass of water, and that would sort of enhance my agency because I would have water here while given a talk, which I would not have been able to do otherwise. Now, to sum that up, what I was telling you, what I do is just to figure out how the human brain adapts its memories and its predictions in order to the structures of the world, regardless of its uncertainties, to the structures that it actually has, the statistical structure, the reward structures, to shape our agency and plan the future. And this is at the intersection of reinforcement learning. Everybody might have heard of dopamine, and it's a little bit like the Coke of reinforcement learning. It just makes everything happen. And then you have memory and replay, another field that I'm very into. That creature there is a seahorse, which is the shape of the hippocampus, literally the meaning of the hippocampus in the brain, which is your organ of memory, and how that leads to planning. And then I look at that also in networks of people or collectives. Now, since Tolman, one of my intellectual heroes in 1948, we have thought about how the cognitive maps are similar between rats and men. We are already outside the field of humans since the 40s when we are talking about what are the kinds of representations the brain learns. We're very similar to other mammals, in fact, in terms of how our brains learn that. It's not very particularly human, some of these cognitive maps. And, to find yourself out of the maze, how do you do that? Now, just to give you a very little idea of how I've tried to expand this idea of Tolman, and this was the organ of memory I was telling you guys about. It's right there inside your brain, like right inside, and it looks like a hippocampus or a seahorse, and that's how you remember things. If you lose it, you're really screwed. So I ask, what is it like? What does it take to have human-like memory, and how do these memories and inferences shape our planning and agency? And to give you an example of that, of how I dissociate between these different algorithms or representations or cognitive maps, what kind of cognitive map could be happening, is that I have a very good friend, Sarv, who lives in Philly, and she cooks a mean fesenjoon, which is an Iranian dish with pomegranate sauce. And that's rewarding for me. And also I have a very good friend, Mani, who plays music, and I absolutely love playing music with him. So I've learned over the years to associate Sarv with food and Mani with music. On the other hand, I know that Sav lives in Philly and Mani lives in Brooklyn. So if I feel like I really need to play some music, how do I do that? One way to do is to think about music, go back to Mani, go back to Brooklyn, or to think about where am I going to go this weekend, Philly or Brooklyn, and then I roll it out, unroll all of the states. That's going to take a lot of time. Another way that the brain could be doing this is if it forms these generalizations or multi-step predictions about what is going to come after a couple of steps, and not just roll it out every time that I need to make a decision. And this is where I depart from Tolman. Tolman thought, you stand at the beginning of the maze, you roll out all of the parts of the decision tree branches, and then you choose one of them. In this case, I'm saying the brain has cached some good things in the world that would lead me to reward already. So I look at how computing at decision time versus caching representations that are multi-step, which one of them is more human? And that's one of the sort of recent studies that I've done. Turns out, just a spoiler alert, humans cache multi-step representations. So the algorithms called the successor representation that emerged in computer science already 30 years ago is more human-like than another algorithm, the model-based learner, which also emerged in computer science first. And people thought that that's how the brain worked. So computer science's development of these algorithms helps us better understand memory, and maybe there's a better algorithm that we will come up with. Just to give you an idea of why that matters for planning, because so far we talked about representations. Now, I showed you 3 states. But if I'm going, for instance, from Princeton to California, it would take me a long time if I wanted to do it Tolman style and unroll all of these branches and figure out which one is going to get me. If I do this the morning that I'm supposed to take my plane, I'm going to miss my plane. So it's way better if I have sub-goals and I can jump through some of them in order to be able to sort of reach there. This seems like a very simple thing, but when it happens at multiple scales, when you have a lot of matrices of these multi-step representations, you form generalizations at different scales. You learn categories. You can plan and understand the world and perceive it at different scales. You can make different scales of prediction. It adapts to the learning of the world. It simply learns just the sort of dependencies in the world, but it goes very far in terms of having an agent, which is a reinforcement learner agent, for instance, a computational agent, be able to make predictions and choices in the world that are fast and flexible and adapt to the world. I have a lot of work in that, but you can ask me about it afterwards. Just to give you a very horrible, fast idea of it, this is the one-step transition matrix. If this state was Brooklyn, and this was Mani, and this was music, it says, oh, from Brooklyn you can get to Mani, and if you have Mani, from Mani you can get to music. But it doesn't have the old traditional view. It didn't have this multi-step. It didn't say from Brooklyn you could get to music. This new view says, you know what? From Brooklyn, you can get to music directly because it can make this further inference and store it. This is extremely important generalization. I couldn't stress that more. Another thing is, if I didn't directly experience all these things, the brain replays things. Another thing that came from computer science as well, the DINA architecture, which is simply the idea that by replaying virtual trajectories, you can train a sort of the representation, although you have very little experience in the world. One of the problems with deep learning is that it uses a lot of samples, and this is one of the solutions to use replay. And so if I just saw on Facebook that, for instance, Mani plays death metal now, apologies to goth people, I might not want to go play music with him anymore. But I didn't directly go to Brooklyn, go to Mani, and hear him play death metal. I just updated this by sort of piecing together distal pieces of information. That is something that this algorithm does. So it has predictive multi-step representations, and it has replay to virtually train itself and make inferences and generalizations to plan optimally. There is a bunch of evidence recently, these ones are my work, and there's other work that I'm doing and other people, that this might underlie place cells in the rats. It might be the optimal approach to find sub-goals if you're trying to find your way around a grid world, which could be any state, could be places or not. It explains temporal context model and episodic memory. A lot of these words might not be familiar to you. I just want to show you that it relates to long-term memory, to spatial navigation, to a lot of different things, to perception of categories, to perception of associations and remembering them. It could underlie such a small and simple algorithm, could underlie a lot of human-like behavior that it has taken years for psychology to be able to characterize, which I think is quite phenomenal. Another thing is that you can have ensembles of them at different ranges. So if this gamma, just think about it as how far in the future am I collapsing together? How far in the future am I sort of generalizing together? 2 minutes, let's see. And so one idea is that you have multi-scales of this. So you have at different scales, at different temporal scales, at different scales of abstraction, you have these cached representations and you can use them flexibly. And that's very human-like in terms of memory and in terms of the evidence that we found. Very importantly, stability or volatility of the environment would sort of clarify how many steps into the future should you generalize to. If the world is changing every 2 steps, it would be stupid to generalize for 6 steps. If you've ever been to a minefield or if you're ever somewhere that is being bombed, you better not make very long-term plans because you might need to flexibly change it in order to just survive. But if the world is very sort of stable and reliable, why the hell not? Cash away many steps away. Plan your holidays next year, summer. But if the world is volatile, you don't know if your passport is going to be invalid by then. Could be for me. You can't do that. And then with sort of deep neural networks, another work that I do is that you can build models of how the brain flexibly switches between these different scales of memory in order to realize multi-scale plans. I'm giving a talk right now. I have plans to go to Stanford in a couple of days. Then I have plans to go to Washington to give a talk in 2 weeks after that. I can do these multiple scales simultaneously because my brain has this ability to switch flexibly between these different scales. Finally, these algorithms allow us to characterize what goes wrong when some of these parameters get messed up. PTSD, my favorite disorder, is one that is about generalization of fear. And remember the organ of memory I told you about, in fact, it shrinks in PTSD. You overgeneralize a particular, very intense, singular or repeated trauma to everything, and a lot of things complete to that. And I'm building computational models based on what I showed you about what parameters change to develop PTSD-like symptoms, and how can we intervene with that by using these computational techniques of understanding what actually is happening in the human brain. And so there are ways to sort of parameterize and play with this kind of generalization and replay parameters to characterize, for instance, rumination or the generalization in PTSD and find interventions to deal with it. Finally, in the sort of another use of these algorithms is that you can simulate different futures in order to understand what interventions to design at the collective level. If you know what each individual agent can be simulated as, then you can simulate collectives of them that are interacting, simulate different futures, and come up with what is the best way to interfere with a future you don't like, and where is the current parameters of what is happening in an institution, taking that institution's future, and how to interfere with it. All right, just to end, I'd like to end with these 2 points about AI and policy. Given all of the things that I told you, AI could decide the welfare of my child, as it is right now. It's being used for welfare. So it needs clear and ongoing regulation, standard test training, reassessment of its algorithms and inputs and outputs. And that could be done by comparing it to human methods, by comparing it to what do we want it to do, by simulating all the futures it could create, and then deciding between them and regulating it heavily so some institution would be culpable. And finally, if AI can remember, plan, and develop disorders like humans, like the stuff that I'm building, it can be used to simulate possible futures and decide between them. And I'd like to stress that. And I'd like to end by saying it's the 200th anniversary of Mary Shelley's Frankenstein. Victor Frankenstein, the handsome doctor, did not name the monster. And the monster, in a lot of lines you read that it says, "You didn't take care of me. Of course I turned into this horrible thing." Let's take care of our monsters and give them names and nanny them.
Hello, everyone. Let me just pull up. Oh, no.
Yeah, just skip that. Oops. We can just close Keynote. Oh no, sorry, Chrome. Yeah.
Got it. Awesome. And it has time. Okay, great. Hello. Thank you so much for having me. I'm really excited to be here. It's been a really interesting and thought-provoking time thus far. So who am I? I'm Madeleine Elish. I am an anthropologist, and I lead the Intelligence and Autonomy Initiative at Data and Society, which is a research institute here in New York. Our work, the Intelligence and Autonomy Initiative's work, is aimed at bringing to bear the perspectives and insights of empirical social science research on the development and regulation of data-driven technologies. So precisely picking up where Ida left off. No, wait. And I must admit, that was a kind of an advanced view. This panel isn't my usual bag of tricks. I'm most often the one to say, but wait, have you thought this through, this being AI technology? But wait, what about the people, the power, the unintended consequences? I usually emphasize that there are plenty of immediate and pressing problems to go around with regards to AI or otherwise intelligent technologies, and that we do not need to look to the far future to come up with problems to worry about. We don't need to think about superintelligence or the singularity. Yes, it's true there's a non-zero probability that the machines we've created may outsmart or mind meld with us, but surely we can think of more important problems to contend with when we think about the purported intelligence of machines and its ripple effects throughout society. So when Caroline asked me to speak about my research, I was of course glad, and I also actually really wanted to take seriously the opportunity to take seriously this panel's focus, to think about what might the future of intelligence hold and what might it should hold. And so I should also say that I'm really inspired and in a way like haunted by a point that Ruha Benjamin made at the Future Perfect conference here in New York this past summer. And she pointed out that the power of inventing future fictions about technology, criticizing as well as creating potential fictions, is not about convincing others of what is or what shouldn't be, but rather expanding our own visions of what is possible. And as she eloquently put it, without visions, we don't know what to build, only what to knock down. So construction, imaginings, as well as critique are ways to challenge existing assumptions and build alternatives to the unacceptable forms of capitalism and racism and patriarchy with which we currently live. And so in this vein, gosh, I'm a little too fast. I keep looking at this. And so in this vein, I'm going to talk about some of my research, but then I'm going to push through and try and draw out some of the implications of these concerns as potential starting points for where I think AI research might go from here. So one of the things that I've been realizing about my research is that it boils down, in a way, to a very simple argument. There is no such thing as autonomy. Autonomous systems, unmanned technologies, the current goal of autonomy in its technical sense, I argue, does not and cannot exist. And in fact, if we are designing for autonomous systems, we are designing the wrong thing. And in a way, my interest is actually unabashedly humanist. And I think we're going to have some discussions about that during the panel. I think that we exist in a social state, and we have obligations and attachments to others, and we are a society of humans, and technologies are just embedded within our society. So I'm going to go into a particular I began to think about some of the problems and issues that arise when we talk about autonomous technologies, about who or what is obscured when we call something autonomous or intelligent, in several contexts. So for instance, in my dissertation, I examined these issues in the context of the US Air Force and the use of what are termed unmanned aerial vehicles, also known as drones. And I looked at, among other things, how huge and consequential amounts of war labor are obscured by calling something unmanned. Honestly, though, the war contexts are extremely complex and much more than I can sort of do justice to in the remaining, 6 minutes. So I want to talk about something that is a little more easily definable or describable, and that is actually about the use of autopilots in aviation and how we might think of those as kinds of proto-autonomous technologies. And in turn, how we might think about how notions of responsibility and action and control are reconfigured in AI and automated technologies. So this work came out of an initial project of the Intelligence and Autonomy Initiative with Tim Huang. And we were interested in understanding how responsibility might change in the context of autonomous cars. And Tim and I, rather than sort of think about potentials in the future, we look to the past. And in fact, we studied the history of aviation autopilot litigation, accident investigations, media coverage, sort of what happened in this historical context when an automated technology was introduced, and how did it reconfigure or not existing social norms of responsibility. And in sum, what we found was that automated and autonomous technologies deflect responsibility in unique, systemic, and often unexpected ways that neither law nor everyday common sense ended up keeping up with. Specifically, our central and counterintuitive finding, which I'm happy to talk more about later, was that while control over flight was increasingly shifted to automated systems, responsibility for the flight remained focused on the pilot immediately sitting in the cockpit in what we viewed as a kind of lopsided way. Because while physical control over the system was distributed in time and space between the pilot, the machine, the designers of the machine, the regulators of the machine, in fact, responsibility was not, and it remained localized on the pilot. And we thought that this was a really important aspect to highlight when thinking about the future of liability and responsibility in complex AI systems. And we described it in our research as a moral crumple zone. So the idea is that just as a crumple zone in a car is designed to absorb the force of impact in a crash, the human in a highly complex and automated system may become simply a component, accidentally or intentionally, that bears the brunt of the moral and legal or responsibilities when the overall system fails. Now, what's important is that the metaphor of the moral crumple zone isn't just about another term for a scapegoat, but it's really meant to call attention to the ways that automated and autonomous systems deflect accountability in ways that we need to be aware of, that we need to pay attention to. And equally, while the crumple zone in a car is meant to protect the human driver, what's unique about the moral crumple zone is that it protects the integrity of the technological system itself. But you may say, design the system better, make the pilot obsolete, remove the human from the loop. But in fact, decades of research in human factors demonstrate that automation, and I would argue by extension AI, does not get rid of human error, but rather creates new opportunities for new kinds of missteps and oversights. Because technology is used in society, deployed by society, among a society of humans who also authorize it as being able to do certain things, and obviously originating from human design. It is humans all the way down. Unintentional long pause. And so beyond thinking about, oh gosh, I'm just off on my slides, excuse me. And so beyond thinking about liability in autonomous systems, I think this research speaks to a more fundamental point, which I think others have brought up throughout the day, which is that we cannot think technology separate as sort of technology over here and society over there, because there will be unexpected and likely negative consequences unless we account for the ways in which technologies not only reflect and perpetuate certain social conditions, but also how they will have ripple effects when introduced into use. No matter how self-contained or theoretically autonomous technology may be, it will always already be implicated in human dynamics. And of course, none of this should come, in fact, as a surprise, because if we look at the long history of automation, we learn, in fact, that new technologies do not do away with the human, but rather obscure the ways in which human labor and social power relations are reconfigured. So one of the lessons I think it's important to take forward from this research orientation, is that I think problems arise in large part when we think about one-to-one replacements between humans and machines, or machine intelligence, and when these kinds of correspondences and equivalences are imagined. Simple equations between humans and machines, I think, do a disservice to both, really. And so when I imagine where AI research should go from here, I imagine the challenge not as figuring out how to make a system more autonomous, or in fact, even actually intelligent, but rather how to improve the points of connection and interface between human and AI technologies. And that is not to find a reconciliation or a smoothing over of the differences between human and machine intelligence, but really to dig into the differences. I don't know, maybe this even means stopping calling machines intelligent. I don't know. I think I may be alone in the room on that, but I don't know, right? Because I think it's a reframing of AI, not as a replacement and not as a partner, but actually as a tool. And a hammer is good for hammering things. And so as Kenric brought up earlier, I think that this actually precisely gets at this idea of ontology. The question, and that in fact the question's future to the key to the future questions around AI research is precisely an ontological one. What can AI be? What might it be in other forms, right? In other modes. So this is my final slide. So in the early 1950s, Kurt Vonnegut wrote his famous dystopian novel Player Piano, about a stratified society with an elite of knowledge workers and machines who do everything. I really suggest you go back and reread it if you haven't read it recently. And the book chronicles the personal and civil unrest that follows. And so there's a passage that I want to close on. One of the characters is opining to another character. People are finding that because of the way the machines are changing the world, more and more of their old values don't apply anymore. People have no choice but to become second-rate machines themselves, or wards of the machines. So I, of course, have to end on a dystopian note. I am a critical researcher. But I want to emphasize this peril of equating humans and machines. And so with that kind of note of caution, I'm really excited to have what I think will be a really interesting discussion with the other panelists. So thank you. If there isn't another slide, I thought we could perhaps leave it on this lovely one. Oh, yes.
Okay, well, thank you both. I'm the moderator today, for this section, and I think one of the things I want to get the most clarity on is the notion of maybe not humanity, but personhood and human centricity. Because the problem as I see it is that we're kind of in a human-centric paradigm, right? And we've been potentially since the birth of agriculture, where we're optimizing for the human population and we're not considering ourselves as pieces of a network, right? And it could be argued that all of our talk about AI is relatively pointless if this agricultural engine continues to destroy the environment and saw off the limb that we're all sitting on, environmentally speaking, ecologically speaking, and with our relationship to animals and plants. So in the design discourse that I'm a part of, this idea of human centricity is often elevated as a sort of like, hey, look, we're not going to put you in the crumple zone. Like, you're not the casualty, but actually you're at the center of this product, right? But that also implies a very sort of individualistic, post 19th century liberalism type of notion of what we're in the service of. So, I think maybe we could get some clarity together on what that means. In my sense is that actually we need to expand the notion of personhood because there are all these externalities that have not been factored into the economy, into how we think and model, actually, and this is where I think it touches your work, is the idea of modeling, right? And what I was trying to get to with the notions that were inherent in the materials that Ross Goodwin chose with the Word Car project was that the sensibility of the world that AI has now is largely occluding the majority of living beings on the earth. And we have no visibility to what they are, but we do know where we can get a shitty hamburger. So, I think maybe if we could start by getting some clarity around those definitions, we might have, what does user centricity or human centricity mean to you? What is human? Like, how is that kind of sitting politically with the discourses around design and even the modeling of, in your case, modeling machine systems on what has worked for humans.
Or rats.
Or rats, yeah, exactly.
So I'm very familiar, having just, spent a long time in the academy, I am very aware of a lot of the kind of growing discourses around things like actor network theory or ideas where people take very seriously, because of some very, very important historical wrongs that have been done by humanism, take seriously the importance of the agency of objects and the need to also think about a network of actors as being necessarily connected. I have to say that it makes me nervous in the sense that I am concerned that when we expand the frame of personhood, we lose important degrees of resolution. And I mean resolution actually in kind of two senses. The resolution of like literally in a camera, right? Things become fuzzy, but also actually when we think about mechanisms of accountability, of resolving issues and problems. And so while I think it's important not to return to the humanism of kind of the liberal Enlightenment, I also hope that there must be some way to kind of account for our interdependency with the world, with the planet, with the oceans, with the concrete on the streets, but still maintain that that we are in a society of humans who are responsible to each other in a particularly unique way, which only other humans can be. That's where I've sort of fallen on this. But I think I see arguments for both, but there's something, I don't know, something about the human.
So I'd like to echo definitely the idea that there's something special about the political and moral engagements of humans, and everything else we could teach an AI to become like us, but it's not really, it's not the same. Could it's in itself develop those patterns? It's possible because they're evolving, and if you make it such that Uber is making these driving cars that have a network and they need to talk to each other, these cars, and so that creates a situation where they could come up with some kind of way to sort of prioritize each other. And if we allow that algorithm certain degrees of freedom, maybe it evolves its own kind of morality of sorts. I'm open to that because in that sense, I think that humans are currently special, but we don't need to always be. Also, if we look at human history, a non-white female was not considered really human or person for all of history, so I didn't have a voice if I was born in many different centuries before this. So even the notion of personhood in humans, who counts as human even among us, is different. And I do think that one of my favorite works, if we're allowed to invoke a little bit of other people's works, frames of war. As a person who survived a war, I know that in a war, the other side is not conceived as human, and that's something that Judith Butler talks about. What is the frame we define as a life that is mournable? And I want to be careful about that. So it's true, humanism and sort of human centrism might lead to excluding people of color or women or people that we are having a war with or people who we would prefer to be our slaves, although we're claiming to be awesome. People who we're saying slavery is abolished, but they're still kind of our slaves. They're still making our Victoria's Secret bras in prison, and they're predominantly black. So there's a lot of different levels of this that I think is academically perhaps more clear, but if you actually look at what is happening in the world, it's not. And as a person who survived a war, I believe in some kind of urgency. So I'd like to stop sort of arguing what's a person or not, but look at agency and the ability to cause harm to what we would consider broadly human. And as long as an AI has the capacity to improve the lives of or harm the lives of humans or societies or nature, I'm happy to call it an agent that needs regulations and has responsibility. And I don't need it to be sentient or super smart, so I totally agree with you. We don't need to sort of worry about that part as much. And I do agree that currently something about humans is special in terms of their political and moral lives, but not necessarily forever. And currently personhood or morality is exclusively human. Who knows what happens after these Uber cars start to develop their own morality?
Yeah, I think it's, again, just to reiterate the point that you made about how personhood is distributed and who defines that notion. This is why I kind of find it problematic in design discussions to sort of say, like, let's do human-centered design. It's like, okay,
Who's
well,
human?
like, I think humans are people that order food delivered to their house in the West Coast, based on the use cases I've seen.
Because human there is actually, what is the word for when, it's a euphemism for consumer, right?
Yes.
Right? It isn't actually about human. It's about like human paying attention to this technology. Like a funny Siri story. I don't know, I type U a lot, just the letter U. It autocorrects to I.
Yeah.
I don't know if that happens to anyone else. Like I just
Yeah, that
assume
happens
like
to me too. Yeah.
Can I add one thing though?
Yeah.
So when I talk about human in this kind of modelings, I mean the human brain.
Yes.
And so as compared to other mammals' brains, and I mean human behavior in some specific tests as compared to others, and then even in humans in mental disorders versus, what would be called, the average neurotypical people. So, so that's a little different from the notion of a consumer.
Yeah, and I don't want to, I mean, this is really important, but I also don't want to keep going. I think there's more to discuss, but also just even the notion of like gut bacteria, right? Like if I don't have my gut bacteria, I'm pretty non-functional. And so that really brings porosity into a very like gut level, so to speak. Okay, so one of the things that I think also, would be important to talk about is with regard to AI. How much time do we have? Just so I know how much time we can leave for a question. Okay, so maybe we'll do one more question, then we'll open it up. Is this, there's a sort of a monotheistic, let's say, paradigm of the cloud, right? That we've inherited subconsciously, or because that's how the business structures were, that there's kind of this cloud, that's where the AI lives. And so the group that I work in at Google does a lot of work on, I guess you could call it decentralized or like device specific artificial intelligence, ML. And so I'm curious, as we've been talking about these systems, I think it's very easy to model a singular system, and I know that network dynamics are part of like both of your research. Is how do you imagine the idea that we might actually live in a future where there is not a singular AI and there are actually many, and what is that kind of, what are the implications for that world from your work?
Well, I think we already do. I think that this idea of AI, I try and never say an AI, but AI technologies, AI systems, I think that I think you have a really good point about like what we need right now are different narratives, different ways of understanding. I think that the term AI is just really unhelpful for like so many reasons, from like what it means technologically. Are people talking about only neural nets? Are they talking about machine learning, right? Like there's sort of a technical vagueness about it, but I think also the fact that these regardless of what technologies we mean when we say AI, they are in all kinds of different places, right? They're like in the DHL system that is helping us get our packages, and they're in our phones. And so they're already, maybe I'm not understanding what you were sort of meaning to say about different kinds of AI, but that's when I think like those are two very, while they may be built upon similar technological structures, they have very different implications and conditions of possibility, which I think need to be traced out and explained and interrogated.
Just to be clear, I think, yes, there are many now, but we do have sort of a cloud-oriented model with, like, for example, the like Siri and pieces of like Google Assistant that sort of always refer to that. But I think also more in terms of like the image or the way that we think it. You know, given that you both have a sort of sense of like how dynamics emerge in networks, so to speak. I'm always looking for a model and a narrative that I can propagate, because I actually think that what we're going to produce is going to largely come from a subconscious story that we ingest rather than any kind of rationalized discourse. I'm really sorry, but actually I think that's what's happening. You know, like we watch a lot of movies with the Terminator narrative, that's what we're going to get. So what can we do to program ourselves, so to speak, narratively to produce, or with images, or, you know.
So one thing I'd like to add to what you said earlier, I think of AI in terms of species, the same way that I think about biological creatures or plants as species, or rocks even, and or cars, I guess. It's a different story if you have an AI that is designed to act collectively in a bunch of cars and avoid accidents and carry humans here and there. Another one that is supposed to model memory and PTSD in humans, and another one that is supposed to decide the welfare of a child or the outcome of politics. These are different species of AI. Particular species of it, or even one particular medium of whatever kind of species of AI you have. So there's that one thing. And on your second point, I am very interested in collective dynamics. I do it with people. Just look at, if I have different graphs of 10 people in different structures talking to each other, which graph structure is going to lead to more convergent collective memories after their conversations as opposed to not. And who should talk first to who in terms of bridge ties as opposed to clusters to avoid information bubbles. So I do experiments with that with multiple humans. But I also use these methods to then, simulate futures and decide between them. If you know these things, then you can design graph structures that are useful. You can look at what kind of AIs and what kind of graph structures are going to lead to what. If I want to avoid an epidemic, which links in a sort of a network should I cause? And if I want some news to propagate very fast, or some new belief, or some norm of behavior, which nodes should be propagating first? So all of these things are part of different species of machine learning that one could do, I think.
Why don't we open the questions to the audience?
Charlie Hudson. Madeleine, I really enjoyed your use of the phrase moral crumble zones. And most software is sold with no warranty, and everything's via limited liability corporations. But at the same time, there's discussion that in the previous section that programs can't own copyright, or programs don't create things. So there is a human who has created it. And do we need software liability? Do we need some way to ensure that there is someone at the, someone eventually to blame?
So kind of two ways to address that problem. One is in terms of when we talk about liability as in legal liability, until there is a completely autonomous car, perhaps likely like without a steering wheel, the human driver is likely to be the one liable, because there's often fine print, which Tesla does, which says never take your hand off the wheel. Right, so like technically, like when you get your Tesla and you put it, I don't know Tesla, but like, right, and it goes into autopilot mode, despite what we kind of think about what that autopilot might be doing, Elon Musk has said in statements, like, you're never supposed to take your hand off the wheel. And so that's precisely the location of the moral crumple zone, that there's like, just, it's a legal loophole that like sticks it to the person that's right there. But in terms of like, should there be, or what other, I mean, of course there should be a human responsible for designing a system. And so I think the interesting question becomes like, how do you trace out the different ways in which we might trace that accountability? Helen Nissenbaum has written a really great article that sort of talks about a number of problems that occur in thinking through responsibility in software systems. But in the case of, to stick with the aviation autopilot, something that I'm interested in is thinking about how we might think differently about certifying systems. So the autopilot is certified as, like, by the FAA as one working technology that is bounded in the kind of like box itself, as opposed to thinking about the autopilot plus the human as the certified system.
Would it be possible to include the landscape in that? Or the animals that live in the landscape, like the deer?
I think that they're already covered by like airport regulations.
Really?
Yeah, I mean, I think like the FAA's. I mean, I'm trying to take seriously your question, and I think they're like.
It's an incredibly serious question.
That isn't what I meant. And I think that yes, it's just a different set of rules. Like, it's a particular, the system is like the aerial vehicle in flight.
Right.
There are no deers in air.
Do you mind if I
For now.
follow up to that? Or? Okay, so if I understood the question correctly, accountability for what an AI does, if that's the sort of the direction of the question. So one thing that I was sort of, and I hope that people who were in the last panel would sort of speak about this too, if they wanted to, that I was asking to the last panel is that I actually think after a certain point of training, the AI is left on its own to make certain decisions, and those decisions are used actually to determine certain things about human lives. And from that point on, it's not a single person that you should be holding accountable. There's been a bunch of sort of processes leading there. So if the data is unequal, the data that went into it for training, it could have consequences for not being good. If the algorithm was not chosen correctly for the kind of unequal or equal data that you have, or if the algorithm was not chosen correctly for the robustness or how fast and flexible it should be changing its learning, it could go really wrong after a while. So it's not just the 23-year-old sipping Soylent in Silicon Valley somewhere in a basement that is responsible for it. It's all of there should be a lot more. So I would sort of advocate for regulations and sort of constant tests that are not unlike education for people, may I say that? It doesn't need to have sentient. The whole point is it needs to reach a certain level before it can have certain inputs or be used for a particular thing. The same way as you wouldn't show, necessarily, not everybody does at least, you wouldn't show necessarily porn or hate speech to a 1-year-old because you're like, oh, it's still being formed. But then we know Microsoft added that sort of AI that went online. Within 24 hours, it became, on Twitter, it became a Nazi just because it didn't know, but it had no other training before that. But if it had had training, if it had been nannied, if I may add, it might have been able to do better than just take whatever statistically was most available. So if that happens, if there are these different steps and regulations of training it, testing it, retesting it, making sure the algorithm is right, making sure it's ready to receive this input that we're giving it without losing its shit, as that sort of Microsoft agent did on Twitter, I think that then you can hold accountable the nanny organization that failed, the algorithm choice person that failed, the data collection or the data provider people that failed. You can find out where did the process fail, and you can actually hold a lot of different levels of hierarchy accountable for a failure of an AI.
I would just add to that I think one of the problems that we have thinking these things is that we don't have an effective image of collectivity in a consumer culture. You know, like we can't sort of figure out how do we make this thing, how do we raise this thing, how do we let it become something, how are we collectively inputting it? When part of the ethic, I think, of AI is that it impacts everyone, right? And so this is the need for like a collective model that we just don't have because we've been like atomized for these obvious reasons.
It's also collectively raised and made. It's not just one person.
Hi. Thanks. So this question is primarily for Ida, but I'm open to anyone else responding to it. So I want to talk about agency. You sort of brought this up, and you had these really interesting terms, distal and proximal agency. And you sort of talked about how that sort of the scope of agency. And then in a couple slides later, you talked about this sort of multi-step ways of sort of thinking and deciding about possible futures. And so I'm interested in kind of, when we talk about scope and we don't talk about scale of agency, scale in both space and time, what are we leaving out of the kind of agency that could be impressing upon us? So for example, when we think about agency, we usually think about acts, like sort of an instance of something happening to someone or to something or some collective. And I'm wondering about the kinds of agency that can sort of be distributed over time that we might not get a sense of until much later on. So for a good example, this is sort of institutional agency and the influence that they can have in our lives without us knowing it for many years. And I'm wondering if you could talk more about that kind of agency.
So I had a slide where I had actually institutional agency as a part of that, how institutions can enhance or diminish. So one work, when I was doing philosophy before I did neuroscience, one work that I did was in fact about something that I called radical autonomy, which is the case where your autonomy, your ability to influence your future relies on changing the structures of the world around you. And that's radical because in order for you to individually increase your own agency, you need to change the world, in fact. And that's why I called it as that in that category. So it does rely on being able to see long-term in order to figure out what is the scope of my agency. And in fact, there are interesting clinical work where if someone has really lost that sense of agency, you would give them a plan so they realize that they can, their acts in the world can have some long-term influence as they see over the weeks that the plant is growing. In fact, their agency starts to sort of, it's not sort of a very well-researched method, but it's something that someone told me after one of the talks that I gave. So there are very sort of fragile ways where distal agency can be manipulated, enhanced, or diminished by trauma, by institutions, by legislations. For instance, if you live in a country where women can't drive, that's clearly sort of restricting your agency. So it's not just individual acts, it's a capacity in general. A capacity to determine a certain sort of a plan and influence the future and bring about certain outcomes. If that sort of addresses your question. And it's definitely, it has the collective agency is a thing, collective memory is a thing, individual agency is a thing, institutional agency is a thing, and I think that we definitely should look at all of these sort of different levels, and that's what I'm hoping to do in the distal future of my research throughout my career.
I hate to do this because the conversation's so good, but it's time to wrap up, and we're going to have a 20-minute break while we prepare for our last keynote. So many thanks to our first keynote and all of our panelists. Thank you.